Okay, so shall I start sharing my presentation?
Yes.
Or yeah, okay.
I started the recording. Hopefully it works.
Oh, get to your device and just select. Without. Can you still hear me?
We are hearing you, Julia. Just can't see
Okay,
your
yeah,
screen.
it's just I'm trying to share with sound, and for some
Okay.
reason, with microphone, it doesn't allow me to do it, but I'll do without microphone. All right. So.
I think it's coming now. Yeah, it's great. We see your screen, Julia.
Perfect. I just wonder why is it not moving to the first slide. Now it should be on the first slide. Okay, good. So hello, everybody. I am Julia Koricheva. I'm a forest ecologist from Department of Biological Sciences at Royal Holloway. Forests are my favorite ecosystem. On the background of this title slide, you can see the forest which I planted with my colleagues in Finland and have been studying for last 20 years. So I really like forests, but why forests are important and why we should study them. Forests cover quite a large area. About 1/3 of all global land area on Earth are covered by forests, and you can see them on this map with these green, dark green colors. So you can see what there is this belt of tropical rainforests near the equator, and then we have another belt in the northern hemisphere of this kind of temperate and boreal forests as well. So they cover quite a lot of land area. They are also home to majority of Earth's terrestrial biodiversity. So there are over 60,000 tree species in forests. 80% of all known amphibian species live in forests. 75% of all known bird species live in forests. 68% of all known mammal species live in forests, and also a huge proportion of various small organisms, invertebrates, insects, and so on. Forests also provide us with so-called ecosystem services. So these are the kind of benefits what we as humans derive from different ecosystems. And they can be divided into different categories. So some of them we call provisioning services. And for forests, the most important provision what they make is wood or timber. And this can be used for fuel as well. But it's not just wood and timber. There is lots of food resources in forests, particularly in sort of warmer climates. Forests are very important sources of food for local people. They produce mushrooms, they produce berries, they produce nuts and various edible fruits, and also source of drinking water. There are lots of various streams which originate in forests. Forests also provide this supporting ecosystem services. So, for instance, they provide habitats for different species. They provide this primary production, basically produce plant biomass, which can be then eaten by herbivores and enters into the food chain. Forests are very important in formation of soils by having tree roots, which prevent the soil erosion, and also play an important part in nutrient cycling. Forests are also important in regulating a number of processes, particularly climate. So especially now in the time what we're living now, when we experience these very rapid changes in climate caused by human activities, it's important to consider how we can use plants such as trees to modify the existing climate, because forests have a big impact on climate. They take carbon dioxide for photosynthesis from the atmosphere, so they reduce concentrations of this greenhouse gas in the atmosphere by doing that. They also release a lot of water vapor from the leaves, which form clouds, which reflect some of the solar radiation and results in cooling effects on climates as well. And these clouds then produce the rain, the precipitation, which also having cooling impact on climate after water evaporates from the surfaces. And of course, forests are also important for regulating and preventing floods and for purifying water. And finally, for us humans, forests have also very important cultural significance. In many countries, in many cultures, forests have, or trees in general, have very big spiritual importance. We like forests, they are aesthetically pleasing places to be. They have big educational importance, but also we use them for recreation, for tourism, for hiking, biking, walking the dogs, exercising, and so on. So forests are hugely important for us. But what's the state of the forests nowadays? You probably are very familiar and heard a lot in the news about deforestation in different parts of the world, about deforestation in tropical forests, in Amazon, and so on. But let's look at the situation much closer to home. Let's see how is forest cover doing in Europe. So our immediate neighbors, France, Germany, Spain, Italy, have somewhere around 30% forest cover. In northern European countries like Finland and Sweden, forest cover is above 70%. So the darker the green, the more forest cover there is. UK is almost the shame of Europe in terms of forest cover. We have one of the lowest forest covers in Europe. We have 12% of forest cover, and it has not always been like that. If we go back several thousand years, we would have something like 85% of British Isles covered by mixed deciduous woodland. And it was largely human activities, clearing the forest for agriculture, for pastures, which led to this relatively measurely 12% cover. Believe it or not, this is something to be proud of, because this 12% is a huge improvement. It's more than double of what we had at the beginning of 20th century. Just before the First World War, the forest cover in UK fell to 5%. And UK was importing timber from abroad in huge amounts. And then the First World War happened. And of course, UK couldn't anymore import the timber during the war, but the timber was very much needed for various industries. So after the First World War, an organization called Forestry Commission was formed. It's a governmental department. It still very much exists in UK. And at the beginning, it had just one aim: to increase timber stocks. The challenge what these people in Forestry Commission were facing is what most of our native broadleaf tree species, such as oak or beech, they produce great timber, but they grow too slowly. You will have to wait many decades if you plant oak or beech before you can actually harvest them. So people in Forestry Commission started to look at non-native tree species in a similar climates to UK, and particularly trees from North America, and particularly conifers. And so after the First World War, that's when we started to have in UK lots of these conifer plantations of trees which came from North America, like Sitka spruce, for instance, which is now our most common tree species in UK. So these trees, these conifers, obviously changing totally the type of woodlands what we have in the UK, from largely deciduous ones to conifers. And also, if you look at these conifer plantations, obviously they are very sort of not very naturally looking. All the trees are the same age. They've been planted at the same time. They've been planted in rows. It's just the one species of trees in most of these plantations. There are these kind of squared shapes of these plantations. But that's an improvement from not having forest at all. And in many cases, that's the future. UK currently has the big plans to increase its forest cover over next few decades, and it will be through planting trees, not necessarily Sitka spruce, because now it has been recognized that it's important to plant native species, and we are now in not such a hurry to harvest the timber, because now the role of Forestry Commission is more into a multifunctional forestry. So not just to produce timber, but make woodlands such that they are good for recreation, good for people, good habitat for different living organisms. But anyway, plantations are likely to be one of the main ways how we're going to recover the forest cover in the future to combat climate change, but also to provide habitat for the biodiversity. And my research over the last sort of 20 plus years have been really examining how this changes from natural forest ecosystems composed of many different tree species to something like this plantation composed of usually one tree species or sometimes even one genotype, so one genotype of the same tree species, how it will affect biodiversity and how it will affect ecosystem functioning and the services what these forest ecosystems provide for humans. And we can envisage different relationships between biodiversity in any ecosystem, but we can think about forests specifically, and ecosystem functioning, the processes which are happening in this ecosystem. So we can imagine that there might be a scenario where there is a proportional loss. So if every species what we lose from this ecosystem, the ecosystem functioning will be reducing proportionally in kind of linear fashion. We can also imagine what maybe if some species in these ecosystems are particularly functionally important and these species are extinct, then it will lead to this kind of immediate catastrophe, the collapse of ecosystem functioning just after losses of very few of these species. And the third scenario, which seems to be supported by majority of evidence, scientific evidence available today, is this rivet redundancy hypothesis, where we can think about ecosystem as an airplane, which is composed of many different parts or many different species or many different rivets. And so imagine you're flying this airplane and a couple of rivets from the wings fell off. Will it lead to immediate crash of this airplane? No, it will not, because there are many rivets in this plane and they are functionally redundant, meaning what they have the same role. They kind of keep the wings attached to the plane and preventing the airplane from collapsing. So maybe when we lose a few species which play the same role in ecosystem, nothing will happen in terms of ecosystem functioning until we reach certain threshold where we will lose so many rivets what these ecosystem functions cannot be performed anymore and they will rapidly reduce. So for instance, if we have in forests several species of birds or mammals which are able to disperse the fruits or seeds of a particular tree species, if one of these species get extinct, these tree species will still be able to be dispersed by other species which perform the same role. But if all of these seed dispersals will get extinct, that tree species will get extinct as well, and that will lead to gradual collapse of this ecosystem functioning. So in my research, I'm really interested in how, what's the relationship between changes in biodiversity in forests and the ecosystem functioning, and what is the level of biodiversity we need to maintain to make sure what forest ecosystems don't collapse and function in a sort of reasonable level. But to do that, you need to be able to monitor biodiversity in forests to see what level it is. And that's not an easy task. So in my talk, I will talk largely about the ways how we can do that and sort of benefits and drawbacks of different approaches. So we have quite a lot of different ways, sort of traditional ecological field survey techniques to study biodiversity in forests and in other ecosystems. And I'm sure you're familiar with some of these. So if we want to study insects, for instance, we can use this entomological net. So we can swipe it across vegetation, collect some insects and identify them, and get an idea what kind of insects are present in that community. And here is Prince Charles demonstrating how to use the sweep net. If we want to study, say, small mammals, we can use live trapping methods. Here a couple of students from my practical field ecology course at Royal Holloway, where they install these live traps overnight, and in the morning they check them and identify different species of mice or voles, what they're caught. So we can use this kind of trapping techniques to identify and quantify the number of small mammals in a habitat in the forest. We can use quadrats in the forest or grassland or here on the beach to identify abundance or quantify the abundance and diversity of sedentary organisms like plants or mollusks, for instance. We can also do these point counts if we're interested in birds. We can walk at transect, stop at a particular point, and say during 10 minutes record how many birds we're seeing around us, which species, and maybe also try to identify some birds by sounds, the birds we can't hear, or can't see but can hear. So we do have traditional ecological field survey techniques for majority of these different groups of organisms. But these traditional ecological field surveys have a number of problems. So the largest challenge is really what you need to know your insects, or you need to know your mammals, or you need to know your birds. You need to be an expert in taxonomy to be able to identify these different species. And if you're doing not just insect survey or bird survey, but if you're trying to quantify biodiversity in a woodland, including all these different groups of animals and plants, that's a really huge task. And very few people have enough expertise. What they, some people might be good in plants, but rubbish in birds or vice versa. So it's a very difficult task, and it's a very limiting expertise to be able to identify, especially in tropical forests where the diversity of this organism is so great, all these different species. So that's a challenge. Another problem with these traditional surveys is what many of them are involving trapping these organisms, what we want to quantify, and sometimes killing them. And that's, of course, not ideal, because you don't want already in habitats which are threatened, where you know what the species are potentially in decline, you don't want to study them using methods which reduce their abundance even further. Because of these difficulties with taxonomic expertise, but also because it takes very long time to identify all these species, whatever trapping technique you used, it's difficult to use these traditional surveys to monitor the sites continuously. It takes a lot of effort, not just to do the field work, but later to catalog and identify all the individuals, what you saw. So it's often impossible or expensive to do this continuously, and that's what we need to do, because we need to know how biodiversity is changing over time when we manage ecosystems in a certain way, or when these ecosystems are exposed to climate change, for instance. Many species are very difficult to observe directly. So, for instance, species which are active at night. If you're doing your surveys during the day, you will not record these species, and it's difficult to survey them at night. Our presence as observers in any habitat will also have direct effect on species behavior. So they might hide, they might stop vocalizing. So you might not be able to detect some species just because you're there. So that's not ideal either. So I'm going to talk about two methods of biodiversity monitoring, which have been developed particularly during the last few decades, which getting in more and more common to study biodiversity, not just in forests, but in other ecosystems as well. And I will show you some examples of how these methods can be used. So one method, what you're probably all familiar with, are camera traps. So these are simply digital cameras attached to the thermal sensor, which detects if some warm-bodied animal passes by, and that triggers the video or photo taken during that time, which you can later look at, identify this animal, save this image. You probably, some of you might have used these camera traps for your gardens at home, or maybe you use them at school. They're getting cheaper and cheaper, and the quality of the footage, what you get, is better and better. Here is the image of the camera trap, which was made by one of the students on our practical field ecology course. She was very good at DIY, and she built herself camera traps very cheaply, just buying a few bits and bulbs in a shop. And she used it to monitor birds in her garden. So what are advantages of these camera traps? One huge advantage is what they are not destructive. So you're just taking photos or videos. You are not trapping the animals. You're really not disturbing them. They enable you to do monitoring long-term because depending on which batteries you are using, you can program these cameras so that they take, that many photos. And they often can last for weeks, if not months, in a field. They will record undisturbed behavior of animals, not in your presence, but that's very good. In addition to just providing you information what this particular species was there, they provide you lots of additional information. If it's a video, you will see how species interact with each other or within a species, within a group. You will also get from these camera traps the information about when during the day this photo was taken, so when this animal was active. You might be able to recognize individual animals by their marks, so you can even monitor the same individual. You can see body condition of that animal sometimes, whether it was obviously ill or whether it's well fed in a good condition, and that could be very important. You will be able to use camera traps for recording nocturnal species as well, because they can take photos during the night, so that's advantage compared to traditional monitoring methods. And the records, what you create by having this video or photographs with camera traps, are permanent and they are verifiable. So I don't know if any of you heard in the news over the last few weeks, there was this huge fuss about potential sighting of the Tasmanian tiger or thylacine in Tasmania. This is the animal which is believed to be extinct. The last known individual of this species died in a zoo in Tasmania in 1936. But because there are so many wild areas in Tasmania, big wild areas with no humans living there, many people believed that maybe there are some populations of this thylacine still hunting there. And of course now with camera traps, it's possible to put these camera traps in these sites and check the footage. And so one of the people who put camera traps in one of these reserves claimed that he got the footage, some photos and videos of a thylacine. And media went into frenzy. Everybody was speculating, is it true, is it not true? And this person submitted his records, his footage from the camera trap to the Zoological Museum in Tasmania, and experts looked at it, and unfortunately they confirmed what it's not a thylacine, it's another marsupial, padamelon, much more common. So some people still believe what maybe it was a thylacine, but experts pretty much convinced based on this footage what it's not. So that's good, because with traditional methods of ecological surveys, it would be just you looking at a bird and thinking, I think it's a sparrow, I think it's this. But if you don't have a verifiable proof, a photo, nobody can confirm whether it was the sparrow or whether you misidentified this bird. So this is a repeatable method as well, so that's good. So what kind of information we can get from the camera traps? We can get information about occupancy. So if we're looking at particular area and we install our camera traps in that area, we might get sightings of animal of particular species, this rhino or this orangutan, in only part of this area. So we know what this species occupies territory in this area, but not here when it's never been seen. You will get data on relative abundance, how frequently you record this animal of particular species on camera in particular area. And you will also get information about species richness, how many different species will you record on cameras in different parts of the area. This kind of information could be very useful, for instance, to decide where to establish nature reserve or national park. Which parts of the area have to be protected because they house particularly high, large number of different species. And activity patterns, so on the footage from camera trap, you will get stamp on when this footage was taken, what time of the day, what was the temperature there. So you will get an idea about how active these animals during the night or during the day, when are the best times to observe them in nature and so on, which could be quite useful. Just to give you an idea of one of the projects using these camera traps, here is my PhD student, Joelle Liddell. She is from Guyana, from a country in South America. Here it is in green, between Venezuela and Suriname in north parts of South America. And Joelle's PhD is funded by WWF. And she's looking at how vegetation, birds, and mammal communities are recovering on abundant gold mines. One of the main causes of deforestation in Guyana are mining for gold. So what is happening is what these little artisan companies, they buy the right to mine, they cut the forest, they dig the soil, the ground, they search for gold, and usually they exhaust these gold deposits within a few years, and then they abandon this site. And so Joelle here is standing on one of these abandoned gold mines, and you can see what there is a little bit of vegetation growing, and there is this old forest behind her. She's using camera traps, particularly to look at different mammals. Which mammal species are using open mines, which mammals are using the edges of the forest, and which animals are present only in interior of the forest. Because it's important to know what kind of functional groups of mammals are present in these different habitats. For instance, if we want to regenerate the trees in this mine area, most of the tree species in tropical forests, they are dispersed by birds or mammals. So in order for these trees to establish on this open mine area, their seeds or fruits need to be brought there by the mammals or birds which disperse their fruits. And if this particular species of mammals are not coming into the edge of this mine or in the open area and only live in interior of the forest, then we have problem with recovery of these mine sites and turning them into the proper forest in the future. Okay, so what I'm going to do now, I'm going to show you a few video clips and photographs from the camera traps. The first few will be from camera traps installed at our Royal Holloway campus. This footage was kindly provided by my colleagues from our department, Dr. Steve Portugal, and his master student, Sam Thompson. So you can use chat to submit your guesses of what these animals might be. So they are all our animals, what we can see in Britain. So the first exhibit, and I'll try to see if the video would play. are these two guys. So you can see what there is the date when the video was taken, the temperature during that time. So this was taken in February when it was fairly cold, +3. It was raining as well. Any ideas what these animals are? You can submit via chat your guesses.
Badgers, Julia.
Yeah, there are suggestions. Okay, I'm trying to follow on my tablet, but I don't see any answers. Okay. Badgers, that's correct. Yeah, badgers. So we have at least 3 badger sets on campus. All right, here is the second exhibit. So this is the same site with badger set. You can see the holes in the ground, but the animal is a bit different. So what is that one? Any guesses? No?
So Willy suggested it's a deer.
It's a type of deer, yes, but what kind of deer? We have quite many in the UK. It's a type of deer, yes. As a hint, it's one of our non-native species. This one is from Asia. It looks a little bit like, to me, it looks a little bit like a pig. It doesn't look very much like a deer. It has this quite round body. It's a muntjac deer. We have quite a few of them on campus, and they are quite common in the UK. All right. Let's try some birds. So these are from our arboretum, our site on Royal Holloway campus where we have trees, different tree species planted. So who is that? It's a fairly large bird, very recognizable, with green body and red hat.
Green woodpecker.
Green woodpecker. Is that? Yeah, green woodpecker. Yeah. So it's good. So this woodpecker, like most woodpeckers, it nests in the cavities in trees, but it actually feeds not on insects on trees, but on ants in the ground. So it it lands on the ground in like open area, and then with his beak and very long tongue, it can extract ants from the ground. All right, it says system audio sharing has stopped because of an error. That's not nice because I was planning to play some sounds, but never mind. Okay, and the final bird from the campus, very colorful one. Very beautiful, one of my favorites. No? Nobody can guess? It's a jay, yeah. So it's a type of corvid, relative of crows and jackdaws. A very important bird for dispersing the seeds of like acorns of oak, for instance. Quite important bird. Okay, I will show you also a couple of photos from camera traps in Africa, because a colleague of mine at Royal Holloway, Dr. Becky Thomas, she collaborates with the project looking at leopards in Africa in different countries. And we're using camera traps to record leopards, their abundance, and they can recognize individual animals using these traps. But sometimes they also get footage of other animals, obviously. And sometimes it's not the whole animal, but a little bit of the animal. So can you guess what this is? So this is part of some African animal. What do you think it is? It's a leg, well, three legs and a bit of tail of somebody.
So Tarin got it. Giraffe.
Giraffe, yes, very well. Yeah, you can guess from the coloration of legs. And okay, what about this? A bit blurry photo, but you can still recognize who that is. So this animal has this quite long spines.
Porcupine.
Porcupine, very good. And finally, what about this fellow? You can see this is part of its head. So it's kind of right-hand side of its head. It's obviously sniffing the camera. Got some interest.
Warthog.
Warthog, excellent. Yeah, it's a type of wild pig. Okay. So you can get these records of different animals and lots of information from these camera traps, but it's not all perfect. There are some issues. So for instance, costs might be a limiting factor, even though they're becoming cheaper, but sometimes you need quite a lot of them because you want to monitor it on many sites. Sometimes the performance is bad in environments which are too hot or too cold or very humid. So they might malfunction in these extreme environments. Perhaps one of the largest problems is what these camera traps are only good for monitoring sort of medium to large sized warm-blooded terrestrial animals, and they're not suitable for monitoring smaller things, insects, amphibians and things like that, which are also important. And of course, even though if you use the camouflage paint, you can, they're still quite obvious when you put them in the environment. So they might be discovered by animals or by humans, and they might be stolen or vandalized or damaged. They can burn in wildfires as well, so you might lose some of this equipment. And also they generate huge amount of footage. So it's quite easy to put them in the field and leave them for weeks or months. But then you will collect all this data and you have to go for all this endless footage of videos or photos to look at what you're trying to find. So that's a bit daunting sometimes. So the second method I want to talk about is passive acoustic monitoring, is when you put acoustic recorders in a field. So you put these recorders, which in this case have two microphones pointing into different directions, some device which can record these sounds, and some batteries. And again, like camera traps, you program them, for instance, to record continuously or take recordings every hour for 10 minutes and leave them there for weeks or months, depending how long the batteries will last. They're becoming cheaper and cheaper. So at the bottom here, you see this newest type of acoustic recorders called audio MOFs. They have a size of credit card. They're very small, so they're less, visible in a forest if you attach them to the branch. And they're quite cheap as well. Like camera traps, they are non-invasive, non-destructive, so they just record the sounds. So they allow long-term monitoring. And unlike camera traps, you can also use them to record smaller organisms like bats, frogs, insects, as long as they produce sounds. The animals does not have to be immediately in front of the camera, so that's good. Because with camera traps, if an animal walks behind the camera trap, it won't be photographed. But with acoustic recorders, it just records the sounds in a particular radius, around the recorder, so it doesn't matter if the animal is in front or on the side of the camera. And you can use these recordings to ID particular species, but you not always need to do that, because you can just use overall recording of the sounds from the environment as an indication of its biodiversity and its kind of ecosystem health. So you can imagine it's like animal orchestra. So those of you who play in orchestra, play a particular instrument, you know what each instrument in orchestra has its own sound. But then when they play together, they kind of feel this, what we call in acoustics, soundscape. So they produce this soundscape. And this soundscape could look something like this. So this is an example of so-called spectrogram from a tropical forest in Sumatra. So on y-axis, on x-axis we have time, and on y-axis we have a frequency of sounds. And you can see what there is lots of different organisms producing different sounds, and each of them occupies its own acoustic niche. So they vocalize in a particular frequency. So orangutan here is vocalizing in the low frequency, birds in higher frequencies, insects in higher frequencies, and bats in ultrasound, so it's not audible to at least to human ears. And so just by looking at this spectrogram, you already can see how full is this acoustic environment with different sounds. And if particular species get extinct due to, for instance, human activities, or their densities are reduced, we will start to see some gaps in this spectrogram. We will see some frequencies where no instruments are playing, and that might indicate that something is wrong in these environments. So one of my former PhD students, Rich Beeson, he used these acoustic recorders in various habitats, including woodlands. So here he is in Richmond Park near London, installing his acoustic recorders on trees. He built his own acoustic recorders, which just consisted of microphones, recorder for bats with ultrasound, recorder for audible sounds, and some batteries. And he built his own recorders because when he started his PhD in 2014, I believe, it was the recorders were commercially available recorders were very expensive. So he didn't have enough funding within his PhD to buy as many as he needed. So he built his own, which we thought at the time was very cheap. But by the time he finished his PhD, the technology developed so much that these audio morphs came out, which are much cheaper, so he could have now bought them at a fraction of the price for which he made this. But anyway, I was planning now to play a few sounds, but I have here a message. Let's see if it, because it tells me what I couldn't share system audio, so I might need to maybe, I'll try to, no, I think it, tell me if you can hear something.
We can hear.
Yeah? Oh, perfect. Okay. So what I'm going, okay, so it's just a wrong warning. It just tells me what I can't share sound, but I can. Perfect. So I'm going to play a few sounds by different animals, which all of these are our British animals. So some of them are from recordings made by Rich in, for instance, Richmond Park. So this first one is it was quite common in Richmond Park. So let's hear it again.
No, we couldn't hear Julia.
No, it doesn't work now.
Let's try again.
Okay, so let me go up to the beginning. Can you hear now?
No.
No? It's very strange.
Did you click?
Yeah, I clicked to play. Yeah. All right. What I might do quickly is, let me just try to stop sharing for a moment. And then I will just try to share again with sound, because initially I had everything seemed okay, but then I got this message what now we can't stop. Okay, so let me, oh. Okay, let me try again. Okay, let's try again. Can you hear?
Yes, yes.
Oh, perfect.
We have an answer.
Okay.
Tarin
So?
is saying that it is all.
It's an owl, yes. It's a tawny owl, to be specific. Yes, that's good. Okay, let me see. Yeah, excellent. What about this one? It's a sound you can particularly hear in autumn in UK around October. Any guesses? It's obviously not a bird. It's a mammal, rather large mammal. No?
A deer, yes.
A deer, yeah, it's a red deer, and it's a male red deer, so it's a stag. They make these sounds when they have rat, and then they kind of claim a harem of females and try to protect them from other males. What about this one? Not a dog. So barking noises, but it's not a domestic dog. No. Nobody?
Not yet.
As a hint, it's also a deer, but much smaller one. Different species of deer. Our smallest in UK.
Munjak.
No. Well, Munjak makes similar sounds. Munjak, even known commonly as a barking deer, but this particular one is roe deer, our native deer. So yeah, both Munjak and roe deer make this barking sound. Okay, let's try a couple of birds. Although the sound, I got again the same sign, but I can't share system audio. So let's see if it works or not. Otherwise, I'll continue. Can you hear it?
No.
No. Okay, so it's the same problem again. All right, well, I think maybe we try to, I don't know why it's doing it to me, but maybe I should continue anyway. Although this one would be nice to, let me just quickly do the same thing, stop sharing and then share again. And sound. All right. Okay, slide. Oh, is it going? Let's go into the beginning. Okay, so the last example I wanted to show you is what using these sounds we can record the record the oh, you don't see the same slide as I do. Okay, now we're moving. Good. We can record the effects of our human activity on ecosystems. So this is Lincoln Meadow in Sierra Nevada in California. It's a beautiful area with forest and meadow full of various birds and other organisms. And in 1980s, a forest company came here and they suggested what they will do selective logging. So they will cut some trees and leave the others standing. So this is like a very moderate version of clear cutting. So you don't just cut the whole forest, you just remove individual trees. And they promised what it visually will have no impact. The forest will be still there and it shouldn't affect any animals because there will be plenty of trees left. And it seemed like after they've done it, visually, the habitat looked the same. But there was a sound artist working in the area, Bernie Krause, and he recorded the sounds of that habitat before the logging. So let's hear how it sounded before. I hope you can hear that. Can you hear it? So lots of bird songs. You can hear the water because there is a stream running through the meadow, but lots and lots of bird songs. And if you look at this spectrogram before the logging, you can see what it's full of these noises made by birds. At low frequency, there is this sound of the water, but lots and lots of birds. And this is how the spectrogram looked next year after they did the selective logging. So visually, the ecosystem was the same. There were still trees there. There was the meadow. But you can already see from spectrogram what it looked very different. Lots of frequencies have not been used by anybody. So let's listen how it sounds now. So you can hear most water. Now but otherwise largely water sound. So that provides the opportunity to use this acoustic monitoring of ecosystems as kind of early warning signal when visually we still don't detect any impact, but things are clearly going wrong. So this is Bernie Krause who did these recordings, and he said what great silence is spreading over the natural world, even as the sound of man is becoming deafening. Acoustic monitoring allows you to monitor the impact of these human activities. Of course, it's not all very easy with acoustics. There are some challenges because it also generates lots of data, and you need skills to analyze this data. You might have problems identifying particular species, sounds made by some groups of animals, but often you don't need it, and you can use various acoustic indices to characterize the whole soundscape. And obviously the problem is there are some animals which don't make noises or very little noise, so they cannot be recorded in that way. Even though now the technology allows you to detect really small sounds made by insects and so on, so it's improving, but there are still a lot of species which don't make sound at all. And of course, there is lots of ambient noise, sometimes by wind, sometimes by rain, sometimes by human activities, traffic, airplanes flying and so on. But sometimes it's actually important to record it as well, because, for instance, a colleague of mine, Sarah Papworth, in our department, some of her students work in nature reserve at the border of Sierra Leone and Liberia in Africa, and they use acoustic monitoring to record gunshots, which indicate illegal poaching activity in this reserve. So that might be useful as well. To summarize, I hopefully showed you how camera traps and acoustic monitoring can provide opportunities for this non-invasive monitoring of changes in biodiversity over large areas and long period of time. And these methods, especially acoustic monitoring, might allow detection of impact by humans which do not yet show any visible signs of deterioration. And that's good, because if we can detect some negative effects at these early stages, hopefully we can, change the way we manage this ecosystem to prevent it deteriorating any further until this ecosystem functions or services will collapse. And from your point of view as young sort of researchers coming into this field, you can see there is lots of opportunities for people who are interested in technology. You need to be tech savvy, past these times when you could just go with SweepNet and without any technology collect the data. There are now these more interesting and useful and efficient ways of collecting data for monitoring the biodiversity. And I think, in the next 10, 20 years, these areas of research will really explode. So I think I'll stop here, and I'm happy to take any questions about forests or anything what I said, if there are any.
Any burning questions? I have some, Julia.
Sure.
I am just eager to install some of these camera traps or acoustic monitors now in my surroundings. So how much they cost?
So these audio morphs, these little acoustic ones, which I showed, I think it depends. They do like this mass selling. So the more people are buying this, the cheaper it becomes. But I think it's now down to something like $30. So they are not expensive. Camera traps, I don't know what's the current price of like the cheapest ones. I'm sure you can find in Amazon in other places. But that would be maybe, I don't know, 30, 40 pounds. You probably can get quite decent one, maybe even cheaper ones. But even cheap ones, they work reasonably well. So, and the prices, as I said, in case of my PhD student, in 4 years, when he started this commercially available acoustic recorders would cost about $2,000. And now it's down to $30. So, and the quality is much better. So I'm sure in a few years it will become even more affordable.
We have one question from Tarin, which is, what's the best way to monitor insect species?
Insect species, you can, for some species, you can use acoustic monitoring, like cicadas, for instance. There is a group in UK at the University of Leeds where they work on recording sounds of pollinators. So they have developed a way to each like species of bumblebee vibrate wings in different frequency. So you can actually distinguish them. And for instance, if you install cameras in meadow, you can record what kind of species of pollinators are coming. Obviously, others like butterflies will be very, very silent, so it will be difficult to record them acoustically. But for insects which make sounds, even for insects, there is a colleague at the University of York. He's recording vibrations made by wood-boring insects. So birds which feed in trunk of trees, you can also detect vibrations and see if this trunk is infected by larvae of some wood borers. So you can use acoustic for insects as well. Not camera traps, unfortunately. Yeah.
Okay, so we don't have at the moment more questions, but I did put up Julia's lecture on the Padlet. So as usual, just check it out and put your questions to the lecture notes, and we will come back to those. And I also put up James' PowerPoint now. So if you still want to check that out with the surgical infection, you can send us questions, and we will either ourselves or with James answer to them. Thank you so much.
Thank you very much, and looking forward to your questions next week.
Thank you, Julia. Bye.
Bye-bye.